evening, and we are in the third lecture of this course, that is additive manufacturing and 3D printing. So if there are any query on the previously delivered content, then we can take queries, otherwise we will directly start today's session. Okay, yeah. So in today's topic, today's discussion, we are going to start about file format. Like we were discussing that during your 3D printing or additive manufacturing process, there is a step that after the creation of your solid model, you need to create the STL file. You need to save your file as a STL. Okay, so there are different ways through which you can create a STL file depending upon the software or the modeling software whichever you are using for converting your CAD drawing into your STL file. Okay, so in today's discussion, we will be discussing basically about this STL file format, how this data is stored in this STL file, and what is the structure of this STL file. Okay, so before going into this, let us try to see this figure in the right hand side. You can see uh, one diagram here, 3D diagram. It is there, maybe it is a human structure. Okay, and you can see this figure has been divided into some triangular shape. Okay, so here you can see there are different types of triangles, some is small and some bigger shapes of triangle. Okay, so what we have done basically, we have tried to represent the CAD model uh, with with the help of some triangular surfaces. Okay, so we are assuming that any 3D form or the 3D object can be approximated by a triangulated surface. Okay, yeah, just a second. There is okay. So I hope my voice is reaching. There was some issue, network issue. Students, can you hear me? Okay, just a second. I think my Bluetooth got disconnected. Yes. Yes. So I hope all of you are able to hear me here. So here we can see we can represent any 3D object by the form of or by the combination of a triangulated surfaces. Okay, so we have triangle, and which are representing some small surface corresponding to that particular triangle. Okay, so here what we are trying to do basically, we are trying to represent our whole 3D model with the help of some triangle. Okay, and what is how this triangle will be stored, and how we will calculate the data corresponding that we will see in the uh, corresponding slides. Okay, so in the case of polygon of more than 4 or more sides, these can be divided into multiple triangles. Like if there are three sides, then we will say it is triangle, and if there are more than three sides, like I have a some surface that is corresponding to that is having 4 sides, so we can divide it into some triangle, like we can create triangle 1 and triangle 2. Okay, so the ultimate objective is that we have to uh, divide the surfaces that are having more than 3 sides into triangle. Like previously I tried by vertical line, you can try by this horizontal line also. you can have one triangle 1 and triangle 2. The ultimate aim is to convert the polygons into some triangles, right? Yeah. Like the surface that is having four sides, it has been divided into two triangle, triangle 1 and triangle 2. Similarly, the surface which is represented by five sides like 1, 2, 3, 4, 5, we can divide into how many number of triangles? We can minimum number of triangles. These may be 1, 2, and 3. Okay. Similarly, 8 sides. There is one surface that is representing 8 sides of a triangle, and minimum number of triangle needed to represent this surface will be 6. 1, 2, 3, 4, 5, and 6. Okay, so this way we can conclude that in order to represent a surface that is having n sides, we will require n minus. We can represent this surface by total number of triangle, or the minimum number of triangle which will be required to represent the surface. This will be equal to n minus 2. Okay, so this is how we will be dividing these surfaces into triangle that are having multiple sides, or you can say that are having sides greater than 3. Okay, so we have to reduce the number of sides of any surface, and in such a way that it can be represented by a minimum number of triangle. Okay, and let us now try to see how these triangles, how the data related to these triangle are represented or are stored in the computer memory. Okay, so suppose we are having a triangle with in x, y, z. These are the coordinate system, and the vertices of this triangle are A is your you can say this is point A, this is point B, this is point C. So the coordinates of point A are 0, 0, 0. Coordinates of point B are 0, 1, 0, and coordinates of these point C are 0, 0, 1. So how we will represent that, we will see. First, you need to list all the vertices. So all the vertices, you can say A, B, C. You know the coordinates of these vertices. Okay, and then you have to use your right hand coordinate system. Okay, so what is the right hand coordinate system? So here by figure you can, I guess you can easily understand what is the right-handed Cartesian coordinate system and what is the left-handed Cartesian coordinate system. So this way, if you use your thumb, your left hand, your thumb is corresponding to your z direction, your arm is corresponding to your x direction, and your fingers are corresponding to your y direction. So this is the left-handed coordinate system, and in the case of right-handed coordinate system, your z is corresponding to again your z direction, thumb is corresponding to your z direction, fingers are corresponding to your y direction, and your arm is corresponding to your x direction. Okay, so in representing your triangles in space, what we are following, we are using right-handed x, y, z axis. Okay, or we are using right-handed coordinate system. Okay, so using this right-handed coordinate system, we are listing all the vertexes in counterclockwise direction. Okay, so like in this case, if you move in counterclockwise direction, what will be the direction of these indicating these vertexes? This will be A, B, and C. Or if you are starting from B, then this will be B, comma C, comma A. Because what we have to follow, we have to follow the counterclockwise direction when we are seeing from your from outer side. Okay, or you can say from front side, or it can be C, comma A, comma B. So this is how a single triangle is represented in the space, and you can see the how this triangle has been the data corresponding to this triangle needs to be stored, like the coordinates corresponding to point A, coordinates corresponding to your vertex B, coordinates corresponding to point C. So this is A, B, C. Second line is representing B, C, A, or you can say C, A, B, right? So this is how we have to save, we have to list these vertices while representing a triangle in the space. So yeah, let us take one more example that we are having a tetrahedron, and in tetrahedron we are having how many vertices? We are having 4 vertices, like this is vertex 1, vertex 2, vertex 3, and vertex 4. Okay, so uh, what is the rule? Rule is that we have to list all the vertices. Then before that, what we are supposed to do? We have to first convert the surfaces, polygon surfaces, into triangle. Then for each triangle you have to list the vertices. You have to list the vertices. Then you have to prepare the list taking the counterclockwise direction when you are seeing from outside of that particular particular polygon or surface, right? Yes. Okay. So from this figure, how many surfaces, how many triangles are there? If you will see, since there are 4 sides, since there are 4 sides, it is a tetrahedron. So and the corresponding vertices are 1, 2, 3, and 4. Okay. So here, how many triangle will be generated in order to represent this geometry? Because there are 4 sides. So yeah. So yeah. Just a second. So here, since we are having this in this tetrahedron, just a second. Give me 1 second. Yes, yes, it is 3D model. Actually, I am searching some more good figure. Yeah. Yeah. So for more clarity, I'm taking a few more figures. Yeah. So here you can see in this tetrahedron, you will have one triangle, then another triangle, 1, 2, 3, 4. Okay. So this is a since this is a 3D object. So how many triangle will be generated? 1, 2, because here you can see clearly from this slide, you might not be able to see clearly the number of surfaces, but I hope from this figure you are able to see clearly. Can you see it? There are how many number of triangles in tetrahedron? 1, 2, 3, 4, 4 triangles are there. Yeah. So four triangles are there, and how we will be storing data corresponding to these triangles. Okay. So like for this triangle, for this tetrahedron, for which I have taken example, you will see triangle. One triangle will be 1, 2, 3, or let me take some other name because you may get confused. Yeah, so this will be instead of, yeah, so let us give this name some name like triangle 1 2 3 is one triangle, right? You are able to see now, it will be representing one set of triangle. Yeah, then you will have one more triangle. You will have 1 3 4, okay, by considering these three vertices. So any three vertices, combination of three vertices will represent one triangle. Okay, so these, how many sets of these vertices will be there? There will be four set of vertices. So this is representing surface A. So what is the surface A? Let us try to see. Let me choose some other color for my highlighter, so that, yeah, yellow, I guess yellow will be fine. Yeah, so try to see, this is your one triangle. Yes. Yeah. Yeah. Okay. Let me see. So let us try to see your surface A. Your surface A is uh, one, two, three. Triangle 1 2 3. Right. It is clear. There is no doubt in surface A. Right. And now we will try to see surface B. So surface B is corresponding to your vertex, this vertex, this vertex, then this vertex. I hope my yellow marker is visible to you or not. Those who are using mobile devices, might be, it might be light. Okay, but okay, let me change the ink. Let me make it black. Okay, so this is corresponding to these three vertices, surface B, right? uh, let us say x, y, and z. Okay, so this is corresponding, the surface B is corresponding to these three vertices. Okay, and if you try to see, when you are seeing from outside, so this will be your viewing direction. This will be your viewing direction because this is in front of you. And if you take counterclockwise direction in this viewing direction, what will be the sequence of vertices? This will be x, y, and z, because we are considering counterclockwise, or you can say z, x, y, or y, z, x. So try to see the surface B. Surface B, this is corresponding to your vertex x. Then which vertex will come when we are starting with x? Then another vertex will be your y. Okay, because we are seeing from outer side in counterclockwise direction. So this is corresponding to your y, and again this is corresponding to your z. Or you can represent it by y z x or z x y. Yeah, I hope it is understandable to all of you. uh, it is actually there is these A is representing one surface that is corresponding to three triangles. Okay, then what this B is representing surface corresponding to this these three vertices. Okay, these A B C are representing, you can say triangular surfaces. C is representing triangular surfaces which is corresponding to these three vertices. Okay, uh, like for, if I take the first nomenclature, then 1 2 3 and 4. Let me make it again. It is 1, vertex 1, vertex 2, vertex 3, vertex 4. So here what has been represented, a triangle A, or the surface triangular surface A is corresponding to vertex 1, 2 and 3, not 3, sorry. A is corresponding to uh, 1, 2 and 4, right? This is your in red color which is shown, this whole surface. This triangle is corresponding to which vertexes? 1, 2 and 4. Surface B is corresponding to vertex 2, 3 and 4. 2, 3 and 4. Surface C is corresponding to, or triangular C is corresponding to vertex 1, 3 and 4. 1, 3 and 4. Surface D is corresponding to 1, 2 and 3. 1, 2 and 3. And now we have to see the sequence, that how we will be listing these vertexes. So the rule is that when we are seeing from outside, the vertex should be selected in counterclockwise direction. Okay, so for surface A we have vertexes 1, 2 and 3. This is our triangle. Okay, and we are seeing from our front side. So what will be the sequence of vertexes? This will be we can take from this side. This will you can take first vertex, then second vertex, and then fourth vertex. That's why it is written as 1, 2 and 4. 1 is 1, 1, 1. 2 is minus 1, minus 1, 1, and fourth is 1, minus 1, minus 1. Right. So this is the sequence of vertex for triangular surface A. Then for surface B, we are this viewing direction is from this side. So this will be, again, if you take counterclockwise direction, this will be 2, 3, 4. So this is how the corresponding coordinates have been taken. 2 is minus 1, minus 1, 1. 3 is minus 1, 1, minus 1. 4 is 1, minus 1, minus 3. Okay, so this is corresponding to surface B. And if you try to see, since the surface C is in behind this triangular surface, so the viewing direction will be from this side. If you want to see from front, then this will be your viewing direction. And in that particular direction, if you see in counterclockwise direction, then your sequence of vertices, listing your sequence of vertices will be, if you because since we are seeing from behind, so this will be in counterclockwise direction. So in counterclockwise direction, if this will come like this if you are seeing from behind. Okay, because we are seeing from behind, so your and if you want to see the sequence of vertices, then this will be 1, 4 and 3. So try to see the sequence of listing how these vertices are listed. So for C, it should be 1, 4 and 3. So let us try to see what are the coordinates of 1. This is 1, 1, 1. Then we need to list the coordinates corresponding to 4. So coordinates corresponding to 4 are 1, minus 1, minus 1. Right. So this is 1, minus 1, minus 1. Yani it is corresponding to 4. Then we have corresponding to 3. So this is 1, minus 1, 1, 1. Right. So this is corresponding to 3. Now try to see for the surface D. For the surface D, we are having just a second. Yeah. So for surface D, we are having the vertices 1, 2, 3. Okay, and since we are seeing from the behind, so again the sequence of listing of vertices will be like this, because we are seeing from behind. Just give me 1 second. there is one call. Yeah, so the triangular surface, or the listing of vertices for surface D will be, for the triangle D will be 1, then 4, sorry, 1, 3, and 2. So this will be 1, 3, and 2. So let us see how this vertex has been, this triangle has been represented. The corresponding coordinate are, for vertex 1 it is 1 comma 1 comma 1, then corresponding to vertex 3 these are minus 1 1 minus 1, right? And corresponding to your vertex 2 these are minus 1 minus 1 1. So I hope it is clear to all of you, or is there any doubt? Okay, so whenever we are seeing any 3D surface which has been represented by the triangular surfaces, what we have to see, first we have to list the vertices, then we have to arrange the vertices when in the sequence such that if we are seeing the triangle from outside. Okay, so this way we can represent that particular triangle. Okay, so yes, so this is the discussion which we will be implementing in our next part of discussion, that how to save this information in computer. Okay, because we know how to list these vertices. Okay, so for this we have one common format, that is STL format, and those who are from computer science background, they might be aware about the ASCII file format. What is the ASCII encoding, that I will not be taking as of now, but you can read about this ASCII encoding on Google. Okay. Uh, Somebody is asking anything? Just a second. Some issue is not. Some issue is with my device. I cannot hear. Why it is not coming? Okay, can you speak again? Hello? Any student? Yes, 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 yes. Tell me. Yes. So I said I hope my voice has reached to all of you. Need not to worry about this ASCII encoding. Okay, we will not be discussing. You can Google it, and because it is not much, much of interest here. Okay, so let me come it directly, because most of you are using WordPad or Notepad for editing your text file. Like let me open one Notepad. Okay, so I hope all of you have seen this Notepad in your computer. Yeah. So don't get confused by this ASCII encoding. We will not be discussing. Okay. So how what we have to do? We are aware that how we need to save this information in using these triangular vertices. How we can represent a surface that is having multiple triangular surfaces. In what way we need to store, or in what way we need to store these triangles in text file. Okay, so how we need to store that, we will be discussing in this part. Okay, so in STL file, it is a simple file. You can say it can be written in any text file. Like I have opened one text file for you, and how you need to store this information. Like you have the first line is corresponding to your solid, that is the solid name, whatever name you want to give, it is not going to much impact. Okay, then every triangle have some 7 set of lines. So what are these 7 set of lines, that I will show you in the next slide maybe. Yeah, so for simplicity, you just remember that facets normal 0 0, outer loop, vertex corresponding to triangle 1, vertex corresponding to triangle 2, vertex corresponding to triangle 3. Okay, here only you have to give the XYZ part for that each triangle or that particular triangle, because what we are doing, we are saving the information, or we are trying to convert the 3D CAD model into a small part of tetrahedron. Okay, some small component of a tetrahedron. So in tetrahedron, how many surfaces will be there? There will be uh, yeah. So we are trying to represent these tetrahedron or triangle surfaces, or any polygon surfaces using these triangle. Okay, and in these triangle, what we have vertex corresponding to vertex 1, vertex 2, vertex 3. Okay, so let me show one example of a tetrahedron. So here what you are having, you are having these 7 lines, uh, 1 2 3 4 5 6 7. Okay, so these 7 lines will be repeated for different triangular surfaces. Okay, and after this these 7 completion of these all the surfaces, you will use and solid name tetrahedron. This is solid name. Yeah. Okay, and what you have to do, you simply save this file as a STL. Okay, let me open it. Yeah, yeah. So my mobile again, it has some issue. No problem, I will be presenting using my laptop. Yeah. Okay, so what I have done, uh, I, I, I have copy pasted this data in one text file, and I am saving it as a STL. Okay, let me open this. Where I am keeping all the demo, I am keeping here. Okay, yeah. So I am saving this file as demo. Hmm, what is today? Today is Monday. Demo monday.stl. Okay, so here you can see I have saved this text file, and where this text file has come, demo Monday, it has been created 21 January. Yeah, this is the current file. So let me open this file in one STL viewer, how it looks like. So here I hope you can see one tetrahedron had been created. Okay, this has been created from which file? from this textual file. Okay, and we can play more with this file. Again, we can close it. Let me close it, uh, and let me show you. Yes, let me show you only one with one triangle. Okay, I have again saved it and open it again. Yeah, I hope it work. Okay, so here you can see only one triangular surface is coming. Can you see it? Yeah.
Yes, sir.
Yes. So you yeah, this is corresponding to one triangular surface, and let me show you one more thing. Let me show you if it works two surfaces instead of
Sir,
yeah.
sir, um, where to run the STL file, sir?
You can open it in any STL file viewer. I am using MeshLab. You can use any there are open source software available for opening these STL file.
Okay, sir.
Yeah. So again, I have saved only two surfaces. Let me see whether it works or not. I'm not sure. Yeah, it is working. You can see two surfaces in your STL file. Yeah. Is it visible? Because I'm not sure whether it will be visible on your
Yes,
screen.
sir.
Yes. You can see there are only two surfaces. Okay. And if you want to show the complete tetrahedron, then you have to again. Uh, yes, this is your complete tetrahedron, solid tetrahedron. This all the four triangles will be shown here. Let me see. So again, I am opening it. Yeah. So here you can see the complete tetrahedron which is having four triangles. Okay. So I expect that at least the student from computer science they will try to see these things, that how to write algorithm to divide the a complex 3D object or the generate triangles for a complex 3D object or to convert it into such kind of triangles. Okay, because ultimately these small triangles, tetrahedron, triangles that has represented to that are used to represent a tetrahedron are used to represent uh, a large 3D object. Okay, a large 3D object can be made by joining these tetrahedron objects. Okay, so for today I will I let me see if there is anything important left. Otherwise, I will stop here.
Sir,
Yeah,
uh, sir, in the
yeah,
code part, sir,
yeah,
sir, it is written that face it normal 0 0 0.
yeah, yeah.
Sir, I think it represent the position of the coordinate axis, no?
Yes, yes. It is representing coordinates.
So, sir, we can change the, matlab, we can change the coordinate
Huh.
0 0 to something else also.
Yes, yes. You try these all the trial and error. I have also tried today. First time. Okay. So even I did lot of homework to represent this example, so that you are able to see the actual situation what happens in the case of when we write something in STL file, something in Notepad, and save it as a STL file, so that we can view it through a STL viewer. Okay, and there sometimes you may not succeed with all the viewer. Like I have installed multiple STL viewer, like it is showing in MeshLab, but when I am trying to see with the default viewer, like let me open it, there are other viewer too, then it is not working sometimes. Let me see whether it is working. Oh yes, it is working for Windows default STL viewer. It is working. Okay, and there are other viewer. choose another MATLAB. It is working. I have one more slicer viewer is there. Yes, yeah, this one. Let me see whether it is working or not. Because you will face multiple issues when you are writing manually. Maybe some coding issue is there. Sometimes the viewer is not able to understand. Demo Monday. Yeah. So yes, right now it is working, but in afternoon I have tried a lot. There was lot of issues, maybe some incorrect, there was some incorrect selection of vertices or some other issues there. So that we have to see. Okay. So it is working with few of the viewer that I have tried. That is Slice 3R, Slicer, MATLAB. It is working. So all these are open source software. You can download these STL viewer from the Google search, and you can check these creation of or saving your file as a STL file, right? So this process, this I have done demonstration. Yeah. So I will stop here. If there are any query, we can take queries, or